So, good morning, everyone, and good morning to Pravina. It's a great honor and privilege to be here today. I would first like to extend my heartfelt gratitude to School Reformers Initiative and to Pravina. You reached me and for giving me the opportunity to be part of this important discussion. Your continuous effort towards improving education inspire all of us. So, my topic is to develop a scientific temperament while teaching science. So this topic is very close to my heart. I think in next 20 to 25 minutes, what I will deliver with you, you may connect with this. So let's start. What we see, it is a natural trait of a living being to be curious about world around them. Compared to the other creatures, this trait is more distinctly evident in humans. Before we explore how we understand science education and important questions arise, what is the objective of science? What is the objective of science teaching? The main objective of science teaching is to develop scientific thinking, reasoning in a student. It is not just about imparting knowledge, but also about encouraging students to analyze problems, make rational decisions, and draw conclusions from their experiences. Science aims to foster curiosity and exploration so the students can understand the world deeply and generate new ideas to improve it. So, as we see, the main objective of science, science teaching, you can see in the slides. I will talk in each of these sections. Uh, the first is promoting scientific legacy, literacy. I'm sorry. So this is very important when a student or a society, connected with the scientific society get more literate towards the science. The social behavior will be automatically will be based on science. So students should understand basic scientific concept like terminologies, process, enabling them to make informed decisions about everyday issues involving science. The second important thing is developing scientific temperament, which is the core of the whole session. Science education encourages curiosity, critical thinking, and an evidence-based approach to problem solving. It helps students to question, analyze, draw conclusions based on data, encouraging inquiry-based learning. One major objective is to engage students in inquiry and experimentation. This involves observation, phenomena, asking questions, forming hypotheses, concluding experiments, and making conclusions, which mirrors the scientific method. The next is real world application. This is one another more important thing when a student reads something in his textbook, and if you couldn't find the same thing in the real world connection, so this is very uh, it becomes difficult to make a scientific temperament. So science teaching aims to help the student connect scientific concept into the real world problems, encourage them to apply what they learn in the practical and meaningful way. So these are the basic objective of the science teaching we have seen here. So if you move to the next section, what happens in our traditional approach? What is the traditional approach in our science classes? Often we found, um, however, we see similarity between the in our classes, similarity between the language and science class. In a language, what happens in a language class? Just as the teacher reads stories from the textbook, in the same way, lessons are often read verbatim in science classes. But the demand of a science class is different. It requires developing skills such as observation, asking questions, and cultivating the habit of inquiry in student. Now let us talk about what an ideal science class should look like. In many classrooms, a teacher begins with a science lesson and introduces the concept of student, followed by an explanation. After teaching a few sections of the lesson, the teacher writes the key definition, and finding the class ends with the answering the questions. Uh, the teacher might ask questions to the student, which becomes a method of assessment. After this, the teacher dictates the answers. Students are expected to write them down. Eventually, students are asked to answer these questions either in written or oral. If the students can answer as expected by the teacher, it is considered that the student has learned the concept. If not, it is considered as assumed that the student hasn't understood this lesson, and the process of memorization and writing begins again. A new question arises here. If a student can answer, if a student can answer, say they have understand. Can we say they have understood the science behind the lesson? The second thing is, if they can't, does it mean that they haven't learned the science behind the concept? We can focus on another question: why do we teach science, and what is the purpose of science curriculum? So we see here few things from the nature. We have to understand the how we can nurture the scientific thinking in our classroom. So if you closely examine the curriculum and the defined learning outcomes for each and every class, we find that the purpose is not merely to make students to memorize scientific concept, but to develop scientific thinking in them. I am not saying to create scientific thinking here, but to develop it, because we observe carefully. Children naturally have tendencies to ask questions, make observations, and experiments with objects. For example, if you give a small child a beautiful flower, they often pluck its petals to see what's inside. If you look back at your childhood, you may recall uh, taking apart new toys to understand how to work. Sometimes you might have successfully reassembled them, while other times you fail. The attempts show that the process of trial and error, which is at the heart of the learning science. In present time, where we are living in the era of internet and information, we receive a lot of information, and teacher should encourage students to develop the skills of testing and evaluating facts in their classroom teaching. This is the best achieved in the science classes. The need for the this arises because, continuing the reasoning here, we explain the importance of the nurturing critical thinking and inquiry skills in students. In science education, encouraging a student to experiment, ask questions, and test their ideas help them build a deeper understanding of concepts and foster a scientific approach to problem solving, which is the key aim of science teaching. We see scientific temperament, how in today's scenario, what we find that in India, we see scientific temperament or attitude is an important part of science teaching in education. Today, in the time of social media and boost of information, it is difficult to understand what is right and what is fake. Discussing with the students on famous fake narratives, asking their logical views on social, political, and scientific topic, it is important. The dominant narrative about the role of science teaching in society is limited, prepared students for IIT and NEET, because these objective moves towards the moving a good economical social status in the society as an individual. But then we find example how people with big educational degrees share fake narratives, hate on social media platforms. People on big posts shows biases and prejudices against each other communities, groups, etc. Science is an important method, process, and tool which has shaped the society from the long time. By the help by the help of the science, we eradicated the idea of magic, ghost behind the communicable diseases, explore how our body parts work. There is nothing supernatural in lightning, disaster, etc. So, teaching and learning science comes with some responsibilities too, and limiting it to the certain exams status is like reducing the importance of science. So, from here, now we'll take how to develop. Now we see how we can develop scientific temperament while teaching science. So there you can see few points as a encourage. You can encourage uh, the inquiry and curiosity in students. Let's start with the curiosity. So how you can create a curiosity? Imagine a child asking, "Why do stars twinkle?" Uh, it is such a question, but it's the starting point of a bigger scientific exploration about the light, atmosphere, and space. When we nurture this curiosity in the classroom, we help a student develop a habit of asking questions about the world. Example, you can conduct a quick classroom experiment. Ask students why they think ice melt faster on metal than on wood. Let them guess, test different materials, and figure out the metal conducts heat better. This small act of questioning and testing builds scientific temperament. Second thing is promote critical thinking. How you can promote critical thinking in your classroom. For example, we can do a small experiment. Present two headlines from the news. One claiming the miracle care of an illness, and other based on a well-researched scientific study. Ask your student, which do you believe? Why? Let them investigate the evidences behind the both claims. This shows them how to evaluate information critically and not take things at the face value. Similarly, the hands-on learning experimentation is very important. What, for example, hands-on, how can a teacher do a hands-on experiment? So you can set up a simple experiment like growing plants under the different light conditions: sunlight, artificial light, and no light. Student can observe and trace which plant grow best. By doing this, they will learn about the effects of light on plant growth. But more importantly, they will learn how experiment provide answers. Even when experiment don't work as expected, that's lesson two. For example, if plant under artificial light doesn't grow, it opens the door to more questioning. Why don't it grow? What factors are different? So similarly, if we see develop observation skill, this is one of the most important skill while we can develop while teaching science we can develop in our students. When teaching about weather, instead of explaining it outright, have students observe the sky for a week and record changes in temperature, wind, and cloud patterns. Then ask them predict the weather based on their observation. It should be how real scientific observe data before drawing a conclusion. Similarly, use the scientific method. How student can use scientific method to understand, make their understanding better. So you can do a small experiment with them in classroom. Let's say you want to investigate how salt affect water freezing. You can guide student through the steps. You can just ask them to observe water freezes in winter. So, question: does adding salt change fast water freezes? Hypothesis could be, if I add salt, the water will take longer to freeze. Experiment: uh, set two balls, one with a salt and another without, and observe what happens. So students will notice that the salt water takes a longer to freeze, leading them to conclude that salt affects the freezing process. This hands-on method helps them to see the power of structured approach in scientific learning. So by this, if you'll see for the more important things, one next point is fostering mind open-mindedness and skepticism. This is one of the important thing here. So in this section, we can prepare students to questioning claims, investigating myths, and open-mindedness. And this very important thing, balance. Uh, how we can understand about the balance? Uh, Encourage your student to find a balance between the being open to new ideas and being skeptical, because in science, if will not doubt in the any result or any thought, will not go for the further actions. So this is very important to make the balance between the openness and skeptical of claims. So from here, at the end, I will just share with you few more things that is very important while teaching science, that is related science to everyday life. So uh, in our classroom, take something as simple as soap. We use it every day, but does why does it work? Conduct a fun experimented by having students dip their fingers in the water with oil on top. Ask them to wash their hands and with wash their hand without soap, and observe the difference. This way, they learned how soap breaks down oils, connecting a scientific principle with something they do every day. Similarly, promote ethical thinking in science. This is very core of the science we see always, uh, to develop the ethical values, because without being ethical, you cannot do a scientific, you cannot perform a scientific investigation. It so when it becomes a value in your life, you will students will be a responsible citizen, or responsible, you can say, a responsible voter. So this is very important. So science should be used responsibly. It's important to teach students not just to discover, but to consider the impact of their discoveries. For example, we can use the example here. Use the example of plastic. Ask your student to research how plastic was once seen as a miracle, but it is now a major environmental problem. Discuss how scientists have a responsibility to consider the long-term effects of their inventions and solutions. The more One more important thing is collaborative learning. So this is one interesting thing which we can develop in a, or which we can include in our classrooms. Uh, since science thrives on collaboration. So great scientific discoveries are often the result of teamwork. Uh, for example, you can stimulate a scientific team in class, assign different groups to investigate different aspects of same problem, such as exploring renewable energy resources, solar, wind, hydro, and geothermal. Each group shares their findings. And other they piece together and big pictures of renewable energy. The most important thing is use technology and resources. So we live in a time when information is at our fingertips. Make sure students are comfortable using modern tools to explore the scientific ideas. So, at the end of my session, I will just share you the few important things. Which types of validity we have to very careful about while teaching or delivering any any content or any concept in science in our classroom. There should be a cognitive validity. So, very focus on these type of six validities. Cognitive validity. When we say cognitive validity, so it is age appropriate content and pedagogical practices. So requires cognitive validity requires that the content, process, language, and pedagogical practices of the curriculum are age appropriate and within the cognitive research of the child. The second is content validity. So content validity requires that the curriculum must convey significant and significantly correct content. Simplification of content, which is often necessary to adapt the curriculum to the cognitive level of the learner, must not be the try visualize as the conveyed something basically flawed or meaningless. The another is process validity. Process validity requires that the curriculum engage the learners in acquiring the methods and processes that leads to generation and validation of scientific knowledge and nurture the natural curiosity and creativity of child. Process validity is an important uh, creation since it helps learning science. And the next is historical validity. Historical validity requires the science curriculum be informed by the historical perspectives in enabling the learners to appreciate how the concept of the science evolved with time. It also helps the learners to view science as a social enterprise and to understand how social factors influence the development of science. And the next is environmental validity. Environmental validity requires that the science be placed in the wider context of the learner's environment, local and global, enabling him or her to appreciate the issues at the interface of science, technology, and society, and preparing him or her with the requisite knowledge and skills to enter the world of work. The last is ethical validity. So, ethical validity requires that the curriculum promotes the values of honesty, objectivity, cooperation, freedom from fear and prejudice, and develop in the learners a concern for life and preservations of environment. So you can see the I have shared the six validities with you here at the end slide. If when you go through the our curriculum, NCRT syllabus, NCRT textbook of science, you can measure and map each and every every validity in in each and every chapter. So at the end, thank you very much to the school reformers once again providing me this opportunity, and I end up my session here. So
Thank
now
you,
we
sir.
can.
Yes, sir. We have only 5 minutes to left. Zoom has sent me a message. I will ask you only a couple of questions. So, what resources are essentials for teachers to develop their own scientific literacy, sir? Do you recommend any resources for the teachers?
Yeah, I will just first of all, if teacher is ready to learn, that is first thing is to every time we have to ready to learn, and the first thing is which you can easily uh, you in your this thing is you can go to the NCRT website and you can download science position paper. So science position paper will help you very much to make better understanding of science teaching. And second thing is, I think the NCRT textbooks of science are itself very helpful. But if we are, always ready to learn, and in this era, in this 21st century, the definition of the teacher is changed. First, we have said teacher as a facilitator, but now we are saying that teacher is not just a facilitator. Teacher is a innovator. So as an innovator, a teacher have to work in his classroom, and these are the resources: science position paper, NCRT textbooks, and I must say, go through NEP 2020 document. That is very important for uh, the particular in particular subject session. So, and apart from that, if anyone more interested how to develop the scientific temperament in ourselves, so there is a book called Sapiens. I must recommend it. That if you will go through the book, you know you will feel the journey of scientific temperament in yourself.
Nice to know, sir. Can you stop sharing the screen, sir, so that the audience can have a better view of you? Thank you.
Okay. Okay. So I'm trying to stop the session. Stop sharing. Okay.
Yes. So the question is related to the students, sir. What feedback can promote student growth and self-reflection from the teachers?
Okay. This is. I think the question is very. This will differ student to student.
Mhm.
What kind of feedback a teacher can provide to a student to make a better understanding of science? Uh, it will, as I said, it will vary from student to student, but basically, uh, if a teacher can create an environment in his or her classroom where the student have a chance or opportunity to observe the things, to collect the data, and to reflect their own thoughts, so this will more helpful for a student or a child to understand the science. Particularly, it is maybe not. I am not able to particularly answer what kind of feedback there should be, but it will
Mhm.
vary student to student.
Student to student. Okay. So, sir, what immediate actions can educators take to cultivate scientific temperament?
So first thing is that, as I mentioned in my session, we have to just change our methodology of teaching science. We have to just differentiate between the language class and the science class. Uh, the science class not should be a like a language class where a teacher coming and just dictating the uh, few formulas, and just the rote memorization is going on in the classroom. We have to just come out from this that comfort zone, and we have to just work on ourselves. I think we have to just make our classroom enrich with we can make our classroom, the first thing is we can make classroom print rich of science. Print rich of science means where the different type of posters and marking should be there related to the science, and there should be an opportunity for a student in each and every class where they can do experiment, small experiment. There should be a teacher can ask the student just germinate few seeds, and after the germination measure the height, how much height the plant is growing in a day. So these are small steps we can do in our classroom. This will definitely help help us.
Great, sir. So, sir, thank you for the talk and for patiently answering all the questions. Anything else you want to mention before I end the session, sir?
So thank you very much. I will just mention thank you to you to providing me this opportunity to present my thoughts here, and sure, I hope we'll meet again in any session.
Sure, sir. Thanks a lot. I'll stop the
So
recording.